Good afternoon, all the students. We'll continue the last class problem. Okay. Uh, Find the trigonometric Fourier series representation of a given continuous time periodic signal. Okay. So from this signal, we identify the time period of the signal equal to 4 seconds. So I consider one on time, one off time. So from this particular point to this particular point, I have taken. Okay. So omega naught angular frequency formula 2 pi by t. So 2 pi by 4, you will get pi by 2 radian per second. X of t mathematical expression. This is look like a digital signals only. It has a constant value of magnitude 1 from t minus 1 to 1. Okay. So minus 1 to 1 magnitude 1. And 1 to 3, the magnitude is minus 1. So t from 1 to 3, magnitude minus 1. Okay. Previous problem, we calculated the expression for your signal x of t by assuming this straight line x1 y1 x2 y2. With the help of this simple formula, it's easy to find out your x of t expressions. Right. Now find out the Fourier series coefficient. It is an even signal actually. For even signal, what are the characteristics? A naught, A and B, and which one is 0? For an even function x of t, bn equal to 0. Or you can try to solve bn value to check whether it is 0 or not. Right. So anyway, a naught and an value we must calculate. So the formula for a naught equal to 1 by total time period, fundamental time period over the time interval x of t into dt. So in this example, t equal to 4, but integration minus 1 to 1 x of t is 1 dot dt plus integration 1 to 3 x of t is minus 1 dot dt. Okay. Now solve this. 1 by 4 t minus 1 to 1 plus minus t 1 to 3. Substitute your upper limit, lower limit. So 1 minus of minus 1 plus minus 3 minus of minus plus 1. Okay. Now check 1 by 4, 2 minus 3 plus 1. So minus 3, 2 plus 1, 3. So plus 3 minus 3, you will get 0. Your A naught value is 0. So AN value, the formula for Fourier series coefficient AN equal to 2 by fundamental time period over the time interval x of t cos n omega naught t. Cos n omega naught t. So substitute 2 by 4 integration minus 1 to 1 x of t is 1 dot cos n omega naught. Omega naught value in this example pi by 2 into dt. Cos n omega naught t dt. So integration 1 to 3 x of t is minus 1. Okay. Cos n pi by 2 t dot. So do the integration carefully and substitute the limit, you will get the answer. Right. 2 by 4 or 1 by 2 cos n pi by 2 sin n pi by 2, and then differentiate this particular term, you will get n pi by 2. Substitute your limit minus 1 to 1. Okay, plus cos n pi by 2, you will get minus sin n pi by 2 divided by n pi by 2. 1 to 3. 1 to 3. Now substitute your upper limit and lower limit. 1 by 2 cos n pi by 2 sin n pi by 2 divided by n pi by 2. So the t is missing there. Now substitute 1 by 2 sin of n pi by 2 divided by n pi by 2, and then minus lower limit sin of minus theta equal to minus sin theta. So that minus into minus plus will get sin n pi by 2 divided by n pi by 2. Okay, this side let minus symbol, let it be minus sin 3 n pi by 2 divided by n pi by 2. Okay, so minus of minus plus sin n pi by 2 divided by n pi by 2. Okay, so now we have to simplify this particular step. So 1 by 2 sin n pi by 2, here sin n pi by 2, here sin n pi by 2. Okay, sin n pi by 2, sin n pi by 2, sin. So n pi by 2 common in all the terms, or we can write it as 2 divided by n pi. If you take a common value, total 3 terms are there, 3 sin n pi by 2. Next, minus sin 3 n pi by 2, minus sin 3 n pi by 2. Okay, so 2 will be cancelled. So 1 divided by n pi, 3 sin n pi by 2 minus sin 3 n pi by 2. So how to solve this particular answer for a naught, a n value? Okay, so recall your trigonometric concept. So let assume this is x coordinate, this y coordinate, okay, 0 degree. This is pi by 2, pi, 3 pi by 2. So this particular axis x comma y, this represent cos theta comma sin theta. So cos 0 1, sin 0 0. So this point might be minus 1 comma 0. Correct? X axis. From this point I know this is positive, this is negative. So if this point is 1 comma 0, this point is minus 1 comma 0. Next. So here it is cos pi by 2 0, sin pi by 2 1. Then opposite side 0 comma minus 1. Okay. So if you have to understand this concept, because I'm going to replace sin 3 n pi by 2 by minus sin n pi by 2. So sin pi by 2, if you look at sin pi by 2, the value is 1. If you look at sin 3 pi by 2, the value is minus 1. Okay, or I can write it as sin pi by 2. Sin pi by 2 is equal to just 1 minute, and reverse side I'll show you. Sin 3 pi by 2. Sin 3 pi by 2. that is minus 1. Okay, so that will be equal to minus of sine pi by 2. Correct? Sine pi by 2 value 1. Okay. So in the previous example, sine 3 n pi by 2, replace sine 3 n pi by 2 by minus sine n pi by 2. There also n, here also n. Okay. So now the an value 1 divided by n pi 3 sine n pi by 2 minus sine n pi by 2. It is minus, it is also on minus plus sine n pi by 2. Okay. It's already on minus available. So sine 3 n pi by 2 equal to minus n. So minus into minus plus. So the resultant value for an now, an equal to 1 divided by n pi 4. 3 plus 1, 4 sine n pi by 2. So this is the answer. So remember this particular concept for maximum problems. In the next problem also we are going to use this logic to simplify the final answer. So the given signal is even signal, that is x of t is equal to x of minus t. See 0 to 1 magnitude 1. Here 0 to minus 1 magnitude 1. Like this 1 to 3 magnitude minus 1. Minus 1 to minus 3 magnitude minus 1. So x of t is equal to x of minus t. So this is an even signal. So for even signal your bn value will be 0. So you can write for the even signal bn value is 0, or you better prove that your bn value is 0. Okay. So for this problem, let us derive the value for bn. We check whether bn value is 0 or not. The formula for bn 2 divided by fundamental time period over the time interval x of t sine nt dot dt. So in this example, 2 divided by 4 integrate minus 1 to 1 x of t1 sine n omega naught. Okay. X of t sine n omega naught. Entity. So omega naught value pi by 2. K into d. Plus integration 1 to 3 x of t is minus 1. So minus sine n pi by 2 t dot dt. Okay. So do the integration 1 by 2 sine n pi by t. So minus cos n pi by 2 t divided by n pi by 2. Can you hear me now?
Yes.
Okay, fine. Okay. So minus cos n pi by 2 t divided by n pi by 2. So substitute your limit minus 1 to 1 plus sin n pi by 2 minus n. So integration sin theta minus cos theta. So that minus minus will be cancelled. You will get cos n pi by 2 t divided by n pi by 2. So 1 to 3. Okay. So substitute upper limit, lower limit, and check whether Bn value is 0 or not. So n by n pi by 2 common term. So take outside. So 2 divided by n pi 2 simply cancel. So minus of cos pi by 2 n pi by 2 minus of cos n pi by 2 first term minus into minus plus cos of minus theta cos theta cos n pi by 2 second term cos 3 n pi by 2, okay, and minus of cos n pi by 2. So minus cos n pi by 2 plus cos n pi by 2. This will be cancelled. And here cos 3 n pi by 2. Cos 3 n pi by 2 minus of cos n pi by 2. So let's check these two terms will be cancelled. Cos 3 n pi by 2. What is the value of cos 3 pi by 2 from this? What is cos 3 pi by 2? 0 comma minus 1. 0 comma minus 1. Cos theta comma sin theta. So cos 3 by 2 value 0. Okay. Cos pi by 2 value is also 0. Okay. Cos pi by 2 value is also 0. So the meaning here cos 3 pi by 2 or cos n 3 pi by 2 or cos n pi by 2 will get same value or 0. So this term also will be 0. Cos 3n pi by 2, 3 pi by 2 0. So everything will be cancelled. Bn value 0. Okay. So if you understand whether the given signal is even signal or odd signal, you can directly write the given signal is even signal. So Bn value is 0. So find only A0 and An component and substitute in the trigonometric Fourier series expressions. X of t equal to A0 plus summation An cos n omega naught t, where n varies from 1 to infinite. So Bn value is 0 here. Okay, so substitute A0 An in this particular. Right. So two problems we solved, and almost 10 to 12 signals are available in textbook as well as reference books. Okay, so I'll send you those signals and how to calculate the trigonometric Fourier series for the given signals. So do you understand now how to apply the Fourier series concept for the signals? So substitute A0 value is 0, I think so, in this particular problem. Yes. So Bn value only available. Sorry, An value. N equal to 1 to infinite cos n pi by 2t. What is An value? 4 divided by n pi sin n pi by 2. 4 divided by n pi. And then sin n pi by 2. So complete your expressions. Okay. Third problem. Find the trigonometric Fourier series for the continuous time periodic signal shown in figure. So I think I could see most of the question paper has this kind of problem. At least minimum one problem like this. T x of t. So what is the signal given? Like this, and so on. Okay. 0, pi, 2 pi, 3 pi. Here it is minus pi, minus 2 pi, minus 3 pi, and so on. The magnitude of the signal is E. Okay. Find the trigonometric Fourier series for this signal. So can anyone remember what is this signal actually from electron devices? And you studied this, some rectifiers and
Half wave rectifier.
so this is the output of half wave rectifier. Right. So whether this signal is periodic or not, first check. The signal shape is like this. Okay. The signal shape is like this. Yes. So some information, then constant 0. Some information 0. Information 0. Right. So this follows some periodicity. So fundamental time period T. Okay. So I consider fundamental time period from here. Okay. T equal to 2 pi. So omega naught value equal to 2 pi by T. So 2 pi by 2 pi, 1 radian per second. Okay. So once the signal is given to you, capital T, fundamental time period we have calculated, and omega naught also done. So what is the next step? Write down the expression for x of. Okay. So first problem, we calculated x of t equation from y minus y1, y2 minus y1 using that expression. Second example, direct, it looked like a digital signals, which has a constant magnitude, so directly we have written. So this kind of problem, you should remember the expression for x of t. Okay, standard sinusoidal signal mathematical expression. In unit 1 we studied x of t equal to a sine omega naught t. Okay, please remember. So this is the mathematical representation of a sinusoidal signal, a sine omega naught t. Here A represent magnitude of the signal. So in this example, capital A available, so you directly consider A. Or in some cases, they will mention the magnitude of the signal, then consider that particular magnitude in your x of t. Sin omega naught. Omega naught value we already calculated. So substitute your omega naught value. Now x of t equal to A sin t. Okay. X of t equal to A sin t. Now it is easy for us to calculate A naught, A and B and value. The Fourier series coefficient A naught 1 by t integration x of t dot dt over the time interval. So what is the total time period? 2 pi. Okay. So now integration. Check your signal. Total time period is 0 to 2 pi. But out of 0 to 2 pi, your sinusoidal information available from 0 to pi only. From pi to 2 pi, 0. So now don't proceed the given problem blindly. You have to check the signal also. 0 to 2 pi complete time period, but 0 to pi only the information available. Pi to 2 pi the signal information is 0. So you have to substitute 0 to pi only. 0 to pi x of t is a sin t dot dt, because pi to 2 pi x of t is 0. Okay, so do it carefully in the examination. Even the total time period 2 pi, your integration is valid from 0 to pi 1. So 1 divided by 2 pi, a is a constant, sin theta minus cos theta. Substitute 0 to pi. So a divided by 2 pi minus cos pi. Okay. Minus cos pi value minus 1. Minus of minus plus cos 0. Sin 0 0, cos 0 value 1. So 2a divided by 2 pi. So a naught value is a divided by pi. Okay. So a naught calculation is very simple. A and Bn involve some formula. Cos A, cos B, sin A, sin B. So those formulas is required to solve the A and Bn completely. Right. An value, formula 2 divided by fundamental time period, integration over the time interval x of t cos n omega naught t into dt. So 2 divided by 2 pi, integration 0 to pi, a sin t. X of t is a sin t. So cos n omega naught t into dt. So use sin a cos b formula. Okay. The formula for sin a cos b, 1 by 2 sin a plus b plus sin a minus b. Okay. Now substitute 1 divided by pi, 0 to pi, or a constant. I'm taking a outside. First expand this format, sin a cos b format. 1 by 2. So 1 by 2. These two will be cancelled. So in this formula 1 by 2 available, that 1 by 2 also constant, take outside. So sin of a plus b, sin 1 plus this idea. Omega naught value in this example 1. Okay. Omega naught value 1. 1 by pi, 0 to pi, a sin t cos nt dot dt. Okay. Omega naught value in this example 1. 2 pi by t, we're getting 1. So sin t cos nt. A plus b, 1 plus n. Sin 1 plus n plus sin of 1 minus n dt. Okay. Now do the integration separately. A divided by 2 pi sin t dt. So we'll get minus cos t, 1 plus n t, and divided by 1 plus n. Substitute 0 to pi plus integration sin t, again minus cos 1 minus nt divided by 1 minus n. Substitute 0 to pi. So and then we need to reduce this equation. So substitute upper limit first. E divided by pi 2 pi minus cos 1 plus n pi divided by 1 plus n. Okay. Then minus into minus plus cos 0 value 1. So 1 divided by 1 plus n. So this is the result from the first term. Plus second term minus cos 1 minus n upper limit pi divided by 1 minus n. So minus of minus plus cos 0 1 1 divided by 1 minus n. So this is the result from the second term. Now cos 1 plus n pi, cos 1 minus n pi. So again we have to go for cos a plus b formula. Okay. Cos 1 plus n pi. Note cos a plus b. Cos a plus b formula cos a cos b minus sin a sin b. So using this formula we can find the expression for cos 1 plus n. So cos 1 plus n cos a cos b. Okay. So 1 plus n pi you'll get 1 pi. So cos pi cos n pi minus sin pi sin n pi. So this term will be 0. So we'll get cos pi cos n pi. Cos pi value minus 1. Cos n pi value minus 1 power n. Okay. So similarly cos a minus b. Cos a minus b cos c cos plus sin a sin b. Okay. So cos 1 minus n pi. Cos 1 plus n pi cos 1 minus n pi. So in this as the previous step you will get minus 1 power n. Sorry, into minus 1. Okay. Now reduce this expression an value. Substitute cos 1 plus n pi. Replace this particular term by minus 1 minus 1 power. So an value a divided by 2 pi. 1 minus 1 power n divided by 1 plus n plus 1 divided by 1 plus n plus 1 minus 1 power n divided by 1 minus n plus 1 divided by 1 minus n. Check. So minus 1, this minus will be cancelled. Minus 1, this minus will be cancelled. So you'll get minus 1 power n only. Okay. If possible, try to simplify this particular step. A divided by 2 pi. 1 divided by 1 plus n plus 1 divided by 1 minus n plus minus 1 power n. If we take minus 1 power n constant, we'll get 1 divided by 1 plus n plus 1 divided by 1 minus n. So this is your answer for A. Okay. So similarly calculate for Bn value. One sec. So A naught An value done. The same procedure you can calculate your Bn value. And check whether this an value we are getting the same expression for even number of n or odd number of n. I think for this example, an value we can further simplify a divided by 2 pi 2 divided by 1 plus n plus 2 divided by 1 minus n for even number of 1. Okay. If n is even minus 1 square or 4 something, you will get this. If n is odd, then this particular term minus this particular term, the result would be 0. 0 for n is odd. Okay. So try to find out Bn value by yourself using the formula Bn equal to 2 by t integration over the time period x of t sin n omega naught t dt, and substitute your omega value and check your Bn value would be 0. Okay. So any doubt in this 3 example? Because trigonometric Fourier series, only 3 problems I have solved, because a lot of problems are available. So I will send you the material for the remaining signals and some problem as an assignment.